Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Izzuddin and I will explain to you about the introduction of our assignment. So, deep learning has become increasingly important in computer vision application such as face recognition and medical image analysis. It is used for performing complex tasks with a high accuracy. Convolutional neural networks, or we can call it as CNNs, designed for image data processing and computer vision, are used in this assignment to recognize image based on the raw pixel data. CNNs learn facial features and classify identities with high precision, identifying and verifying individual based on the raw image data. This data can be used to solve social problems as CNNs provide an accurate and secure framework for analyzing complex patterns in social data, enables effective solution to real-world challenges. The next part is about the objective of this assignment. First is to develop a deep learning based facial recognition system using CNN algorithm with TensorFlow to detect faces from image and classify them. Second, to explore more on implementing a CNN model architecture for image classification and train the model on label facial image data. The last one is to evaluate the trained model's performance on unseen validation data by analyzing metrics such as accuracy and val loss. In this assignment, we also use the dataset from an open source platform called Hugging Face that can provide models, dataset, and application. The dataset was in Parquet format, which is well suited for distributed computer system and is optimized for the efficient storage of massive tabular data. The dataset consists of facial image of various individuals and has been stored as a raw image byte data. Each of the image entry includes file name, which is contain the person names and image number, and image, which is the raw JPEG bytes for each facial image.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazil Razin Birajinda, and today I will be explaining for the algorithm part of the assignment. So, the architecture part implemented in this assignment, it is composed of series convolutional activation and pooling layers, followed by fully connected layers of classification. So, the model consists of following layers, which is start with input layer. So the input shape for the model is 160 by 160 with three color channel pixels. And then the next layer is convolutional layer. So convolutional has three layers. So the first layer it has conv 2D with 32 filters and a 3 by 3 kernel and a reload activation function. And second layer have conv 2D also, but with a 64 filters. And for the third layer, it has 100 to 128 filters. So move on to the next layer, which is pooling layers. So each convolution layers is followed by a max pooling to the layer with a 2 by 2 pool size, which reduces the spatial dimension of the output from the convolutional layer. So the next layer is the flattened layer. So after the convolutional and pooling layers, a flattened layer convert the 3D output into a 1D vector. So it is for preparing the data for fully connected layers. And then let's move on to the next layer, which is dense layer. So dense layer has hidden and output layers. So for the hidden layers, it is a layer with 100 to 8 units and reload activation function. And for the output layer, it has num classes units, which is 422 in this case, and softmax activation function. So the softmax activation function is used for multi-class classification to output probability distribution over the classes. So that's all for the architecture. Okay, so for the next part of the algorithm, it is the additional techniques that we use for the assignment. So we start with image pre-processing first. So image are resized to 160 by 160 pixels, and then it is normalized by dividing by 255.0, and then we scale them to a range between 0 and 1. And then for the next technique, these are data splitting. So stratified shuffle split is used to divide the data set into training and validation sets. So it was split into 80% training and 20% validation, while maintaining the proportion of samples for each class. So the other technique is label encoding. So a label encoder is used to transform categorical text labels into numerical labels. Other encoding is one hot encoding technique. So two underscore categorical. This this technique converts the numerical labels into one encoded format, which is suitable for multi-class classification problems. And for the next technique is dropout. So a dropout layer with a rate of 0.5 is included after the first dense layer. So this technique randomly set a fraction of inputs units to 0 at each update during training, which help prevent overfitting. And so for the last technique that I use, this model compiler. So the the model we use for compiling this model is the Adam optimizer, and then the loss function we use is categorical cross entropy. It is used for it, which is appropriate for multi-classification problems with one hot encoded labels. And the metrics is for the model to track every accuracy during the training. And that's all for the algorithm part of the assignment.
Bismillahirrahmanirrahim. My name is Shafiq bin Yusni, metric number 220697. Now I am going to perform live demonstration of our code. So first part of our code is the import of necessary libraries such as TensorFlow, scikit-learn, Pandas, NumPy, and also image. Then, since I am doing the coding on Google Colab, I will be accessing our dataset file from the drive. So I'm mounting this Google Colab to drive, and then I will read the our dataset file, which is a .parquet file, and save it to a data frame. So our dataset contains two columns, image and file name. So the file name is the name of the corresponding image. Then we will extract uh, the file name column in dataset to create a new column called label in our data frame. Since we have uh, many datasets that contains less than uh, 5 instances, for example, there are about 4,000 classes that contains only one instance. So that is not useful for our CNN algorithm learning curve. So we are going to select only classes with more than 5 instances. So that's what we did in this code. And after that, we will gonna convert raw image bytes into image arrays and save it in a NumPy array. And we normalize the image arrays so that the algorithm can learn better from the normalized value. Now we will perform stratified shuffle split. So we will get two sets from our datasets, which is training sets and also validation sets. Represents features, while Y represents labels. And we will encode our label using label encoder using a one-hot encoding technique. So from labels originally which are name, it will be converted into integers 0, 1, 2, 3, and so on, so that we can feed the features values into our CNN algorithm. So after going through all the steps, we found that our features and labels contains 4,789 images, and the dimension of the image is 160 pixel by 160 pixel, and there are three channels, which is RGB, red, green, and blue. And there are 422 distinct classes, or say faces, in our dataset after the pre-processing process. Now we move on to the model architecture building. We are building a convolutional neural network. So this is our architecture of the CNN algorithm. We have three convolutional layer. The first consists of 32 pool size. Second one is 64, and the third one is 128. Each convolutional layer followed by max pooling 2D. And at the output layer, we flatten the 3D output of convolutional layers into 1D vector. And we call layers.dense to fully reconnect the dense layer. And we use dropout with value of 0.5 to prevent overfitting. And lastly, the output layer, we use activation function of softmax. So we will train the model. For our model, we use Adam optimizer with categorical cross entropy loss. And this model will train in 50 epochs with batch size of 16. So we pass into the model the features training sets of features and also labels. And after 50 epochs, we found that validation accuracy is about 27% with a loss value of 6.4881. And we run a simple confusion matrix. And after that, we will plot our model performance. We plot two metrics against epochs. The first one is accuracy over epochs, and the second one is loss over epochs. So the blue line is the training sets, while the orange line is the validation sets. We see that the validation sets performs worse than the training sets for both metrics, accuracy and loss. That is because our dataset contains imbalanced classes. So some classes has many instances, while many classes contain very little instances. So that's why the accuracy is quite low. But when we try to predict using random images using our train model, it performs quite well, I would say. Sometimes it got wrong prediction. Sometimes it predicted correctly. For example, in this example, the predicted person is Michael Bloomberg, and it is indeed Michael Bloomberg. While other time it may get wrong prediction. So that is all for live demonstration. Thank you. In conclusion, this assignment provided valuable insights for us in the development and the evaluation of a convolutional neural network CNN for facial recognition. We learned that advanced techniques such as data augmentation, regularization, and early stopping are effective in theory, but their impact is dependent on the quality and balance of the dataset. The most consistent performance from our experiments was achieved using a simpler CNN model, especially after filtering out classes with very few samples and applying stratified sampling to maintain class distribution. These findings highlight the importance of data preprocessing and the fact that model complexity alone does not guarantee improved performance. Overall, this assignment helped us understand not just how to build a CNN, but how to approach real-world challenges in data processing and computer vision. Thank you.